Hello everyone and welcome to today's live stream. Today we're covering the third hotfire for our Toothless battleship engine here at Space Team Aachen for Project Astrid. And I think there's no better way to introduce you to our project and what we're doing today than a video from our project lead.
Hello and welcome to our live stream. As you probably already noticed, this is a pre-recorded message as I am probably very busy at the moment. Today we are conducting the third hotfire test of the Toothless engine of Project Astrid, and because of that we already have a lot to show you. So who are we? We are Space Team Aachen, a student association with over 200 active members working on rocket projects and different scientific experiments. My name is Jacob. I am propulsion lead here at Project Astrid, and our sub-team's goal is to get the rocket up into the sky. And this test today is a crucial step in the process of verification that we achieve this goal. For today's live stream, we have prepared different video clips showcasing what the hotfire test is all about. We will showcase the engine, we showcase the Poseidon water deluge system. We have a message from the university. We have clips of the other teams from Space Team Aachen. And I hope you enjoy the show. And with that, I'll leave you onto the live views of us preparing the hotfire test, and see you soon.
I think that video should have given you a nice introduction into what we're doing today. And the main goal of, one of the main goals we have today for this test is that we want to try our water deluge system. We already tried it in our last test, but there were slight mishaps maybe. And I think you'll learn way more in the next video clip we prepare for you guys. Hope you all enjoyed it.
Welcome back. This is the Poseidon water deluge system. Here around the corner, water gets sucked from the 1,000-liter water tank through the KSB pump and here into the injector ring. The injector ring consists of 36 nozzles, and they blast water into the engine's exhaust plume to drastically reduce sound levels. Why all this effort? Our Toothless rocket engine is so powerful that it generates noise levels way above what is allowed here in the neighborhood. So because of that, we have to reduce sound levels drastically. During today's test, we hope to reduce sound levels by 6 to 10 decibels. Keep in mind that is almost a 3 times reduction
Okay, it looks like we're back. We just had a small hiccup there with Ederome. I think every student knows that issue. Haha. And as you can see on screen right now, we are in the supercharging phase right now. That means we are preparing to put some extra pressure in our fuel tank, in our oxidizer tank actually, hybrid rocket, so we have solid fuel. But yeah, so just some extra pressure in the tank to get our right mass flow for the hot fire. And yeah, we are preparing for that. But I think our last video for the water deluge system was cut off, so I'll just replay that for you guys.
Welcome back. This is the Poseidon water deluge system. Here around the corner, water gets sucked from the 1,000-liter water tank through the KSB pump and here into the injector ring. The injector ring consists of 36 nozzles and they blast water into the engine's exhaust plume to drastically reduce sound levels. Why all this effort? Our Toothless rocket engine is so powerful that it generates noise levels way above what is allowed here in the neighborhood. So because of that, we have to reduce sound levels drastically. During today's test, we hope to reduce sound levels by 6 to 10 decibels. Keep in mind that is almost a 3 times reduction in noise. And now let me show you the heart of this system, which is the KSB MovieTech 15C water pump. Let's go. This pump provides a water flow of 500 liters per minute at a pressure of around 5.5 bars. It can produce up to 10 bars at a lower flow and it's an absolute beast. I mean, just look how big it is. The pump is operated by this control panel right here and it allows us to remotely activate the pump from mission control, and it has a safety shut-off feature when water levels are too low. So yeah, huge thank you to KSB for providing us with that pump. It's an absolute beast. And right now, why not show you the Poseidon system at full throttle?
While we wait, I will give you a quick introduction to Project Astrid. This is our mission. We want to launch at the Euroc 2026 competition. It's a rocket competition in Portugal, and there you can launch at target altitudes from 3 to 9 kilometers, and you can test a lot of different new subsystems. And our goal is to launch in the 3-kilometer hybrid category, and we have a lot of new innovative subsystems we want to test there, and of course a successful launch and landing. This is our team. We are 30 students in our different subsystems. My team, propulsion, structures, simulations, recovery and avionics. Recovery obviously is responsible for the recovery, safe recovery of the rocket. Avionics does all the electrical stuff and all the programming for sensors and active flight control. Simulations does all kind of mission analysis and simulations for example, aerodynamic flow. Structures is responsible for the structure of the rocket. They develop the bulkheads that connect our different body tubes of the rocket. And of course propulsion, and we develop the engine and everything that keeps the engine running. This is Astrid. Astrid is 4.5 meters long with a diameter of 18 centimeters, a lift of mass of 55 kilos and a flight duration of roughly 3 minutes. This is the rocket structure. Starting at the bottom we have the fin section in which the engine is located. Above that, lower recovery section with the main parachute and the first airbag. Above that, the N2O tank, that's the main oxidizer tank, a tank with 15 liters of volume. And again, above that, the N2 tank, it's responsible for pressurization of the flight engine and deployment and pressurization of both airbags. Above that, air brakes. These are responsible that we reach the target altitude of 3 kilometers precisely. They have small flaps that extend during flight, controlled by a flight algorithm, and that's how we try to reach this precise altitude. Above that again, drogue parachute and the second airbag in the upper recovery section, and in the nose cone is our payload section, where we fly different experiments. This is our mission profile. Launch at T-0, 6-second burn time, then drogue deployment roughly 30 seconds into flight, then 90 seconds of drogue descent. After that, main deployment and airbag deployment, which takes roughly 20 seconds. And then after 3 minutes, a safe landing. If you want to get in touch with us, this is our project lead, Malte. You can contact him directly. You can become a supporter of Space Team Aachen. Check out our website, and with that, I will leave you with the live stream.
Check. Next step is engine personnel take drone. And place drone outside and start recording on additional cameras.
Com check.
Com check.
Drone.
Check. Now start recording on additional cameras.
There's someone, but we have still 7 minutes. That's okay.
Yeah.
Or I will go outside and
Yeah.
I will go outside.
Okay, short hold. You can still start recording on the cameras, but we have people in behind the fence, so our safety officer is coming down and clears this issue.
Check. Check on all additional cameras.
Check. Okay, next step would be to arm the engine, but we will hold until the area is cleared.
Check. Meister coming back. Seems to be resolved.
Issue resolved?
Yes.
So what's the plan? Is she going?
She's leaving.
She's leaving, okay. Okay, area cleared, so we can continue with the arming of the engine. Don't forget, if the engine is armed, do not walk inside in front of the engine.
Check. Engine is now armed.
Check, engine is armed. Open Poseidon main valve, walk behind the container.
Main valve is open.
Check, next step is drone up in the air.
Okay, we have water dripping out. Everything
Water
fine?
dripping out of the system, which is good.
Drone is in the air.
Drone is in the air. Next step is clear all danger zone. Engine personnel, please come upstairs. Check, engine personnel is upstairs. Close mission control door.
Mission control door closed.
Mission control door closed. Check. Okay, that's it for the pre-test phase. We are now waiting for the T-1 minute hold for the final checkouts. So we still have some time. Okay, close V2. Close V3. Disarm test bench, very good. Okay, we are now entering the T-1 minute hold. Control personnel, check all data for plausibility.
Check.
Check. Check ignition sequence parameters.
Check.
Check. Safety start continuous range check. And give me a
Check.
go if the range is clear, but continue the range check after that.
Range is clear.
Range is clear, check. So we're now in the final go, no go poll. Go from engine,
Go.
go. Go from mission control,
Go.
go. Go from range,
Go.
go. So the next step is the 1 minute warning siren. I will count from 3 to 1 and then the known procedure. 3, 2, 1, on, off, on, off, on, off. Okay, next step is arm Poseidon.
Poseidon is armed.
Check. Pull red button, turn on valve and ignition key.
Test bench armed.
Test bench armed. And now we are leaving the T-1 minute hold. So the next step is start ignition sequence.
Starting ignition sequence.
Ignition sequence started. We have no stream error, which is good. Check. Okay, T-30, safety officer stop rotating PCC cam in the SWL position. And check for Poseidon. T-10. T-3, 2, 1, ignition. Charging begins. Ignition successful, test successful, cut microphone.
Hello, hello, hello. I hope you enjoyed today's test. It was quite successful. We had no issues on our end. We faced some issues with the internet connection. That's why it delayed a bit. Yeah, the test was super successful. We could hear the noise being lower than last test. It looked phenomenal, and I hope you enjoyed the show. And with that, we leave you with the live views for a second. For those interested, you can still watch. And then we will eventually turn off the stream. Like and subscribe to see more streams like this in the future. And with that, we would like to thank the chair of high pressure gas dynamics. That's where we're testing right here. We want to thank the university for the shout outs on Instagram and for the ongoing cooperation. And we would like to thank all of the sponsors that are involved in this process. It really means a lot, because without these sponsors, we couldn't do anything that happens here. Big shout out to the sponsors, big shout out to the other RWTH institutes that support us in manufacturing, support us in testing all of the different things we need to test. And with that, we leave you with the live views. Hope you enjoyed today's test, and see you soon.